Good evening, students. Yesterday, that means previous video, we have seen the SP3 hybridization in the case of methane and SP2 hybridization in the case of ethane. Today, we will see the SP hybridization in the case of ethane. So, here SP hybridization and the example is ethane and the structure is CH triple bond CH. Here I wrote C1 and C2 because actually both the carbons are same in all respects, but for discussing purpose, so C1 and C2 I wrote here. And if we take C1 here, its atomic number is 6 and electron configuration is 1s2, 2s2, 2p2. And in the ground state, this is that is the outermost shell, and outermost shell electronic configuration is like this. So this is 2s, this is 2px, 2py, 2pz, and in 2px that means this 2s, 2 electrons are available, and here this 2 electrons in the p orbital are available in 2px and 2py, and this pz orbital is empty in the ground state. But in the excited state like this, we have to write like this 2s, this 2px, 2py, 2pz, and this the electron here in the 2s will shift to 2pz orbital. So in the excited state, the electronic configuration is like this, 4 electrons. And we are talking about sp hybridization, that means one s orbital, one p orbital, both are combined to form hybridization. So from here only these two orbitals are hybridized, and these two are as it is remaining on the plane of the carbon. This is for one carbon. So here one s orbital which is spherical shape, one p orbital which is dumbbell shape like this. Both are hybridized to form two numbers of sp hybrid orbitals. Two numbers, that means one s orbital, one p orbital, both are combining to form two numbers of sp hybrid orbitals. So these two hybrid orbitals are arranged like this. This is one sp hybrid orbital, assume this is another sp orbital in a linear shape, so here in this one electron, two electrons are there, here one electron, here one electron. So those two electrons will be here like this, and this is two sp hybrid orbitals for one carbon, C1 carbon. And in the same way, totally same way, all for the C2 also happens, and for that C2 also two hybrid orbitals are formed in the linear shape, and those two will be arranged like this. One is this one hybrid orbital, another is this one, another sp hybrid orbital for the C2, like I mentioned here C2, that is for this one, and for C1 hybrid orbitals are these two. Okay, so in this C2 also, like C1, here electrons are there, one electron form bond with the already C1 hybrid orbitals, and another electron will remain here like this. And now this C1 has one hydrogen, C2 has one hydrogen. Hydrogen means 1s1, 1s1, 1s1. So it is spherical shape and it is having one electron. So here one hydrogen with this electron it form bond. Here another hydrogen is there, so that also spherical shape. it forms a bond like this. Like this, total C1 hybrid orbitals and C2 hybrid orbital, one carbon, another carbon forms one sigma bond. This is sigma bond. CC, this is C, this is C. So this is CC sigma bond, carbon carbon sigma bond. This is CH sigma bond, CH sigma bond. This is also CH sigma bond. So three sigma bonds are available here. And here if you see, one p orbital is as such, another p orbital is as such. Two p orbitals are as such, and they are exactly situated parallel, and another p orbital of one carbon, another p orbital of another carbon. So like this. So here for one carbon, one electron, another electron. For second carbon, this electron, this two, this electron, this electron is this one, this electron is this one for one carbon. For another carbon also, this is one, this is one. Okay, so these two will form bond, and these two will form bond above and below. So if this is the plane, then this orbital and this orbital are perpendicular to the plane. This is y direction, this is z direction, this is x direction, this is y direction, this is z direction. Both both the orbitals are perpendicular to each other, above and below the plane. Here also bond, here also bond, like this. So if we write, this is carbon and this is also carbon, and carbon carbon sigma bond is available, and carbon hydrogen sigma bond is available, and this carbon hydrogen sigma bond is available, and this is one pi bond, this is another pi bond. That means here H is there. That means this is sigma bond, this is pi bond, this is pi bond. That means in acetylene totally two pi bonds are available, two pi bonds are available, and in here totally one sigma, one CC sigma bond and one CH sigma bond and the CH sigma bond. That means two CH sigma bonds are available and one CC sigma bond is available in the case of ethine. That means it is also called acetylene. This is also called acetylene. So this is the bonding in ethine using SP hybridization, totally SP hybridization. Okay, so in the previous videos we have discussed SP3 hybridization using methane and ethane examples, and SP hybridization using ethene example, and here SP hybridization using ethine example. Ethine example. Here generally the number of bonds between CC carbon carbon is called bond order. Bond order. Okay, here the bond order in the case of acetylene SP hybridization 3. Here the bond order is 2 because 2 bonds are there, CC. Here the bond order is 1. That means if bond order is more, that means 3, bond length is short. Bond length is short. This bond length is short. This is longer way. This is still long bond compared to this two. So bond length is SP3 hybridization, more bond length will be there. For SP2 hybridization, this one less bond length will be there. So this is more SP2, and SP is still less bond length. So in the case of sp3 hybridization, bond length between cc carbon carbon is 1.54 angstrom units. In the case of sp2, bond length is 1.33 angstrom units, and in the case of sp, this bond length is 1.2 angstrom units. So this is bigger one. After this sp2 hybrid is this bond length, and after that sp hybrid means sp hybridization, this bond 1.2. So if bond order is more, bond length is less. Okay, and the angle between this orbital and this orbital is 180 degrees. So this is linear shape. So here in sp3, shape is tetrahedral. Here sp2, it is planar trigonal. In sp, it is linear structure. It is. Okay, so this is about the hybridization. If you see the previous videos also, you will understand the hybridization in methane and ethane, and sp2 hybridization in ethene, and this is sp hybridization in the case of ethyne. Okay, come here. So here you have seen this ethene and ethane are explained in terms of use of sp3, sp2, sp hybrid orbitals with carbon atoms in the respective molecules. Okay, so hybridization influences the bond order, just now I explained you, and bond enthalpy also. Bond enthalpy means strength in organic compounds. That means here if 3 bonds are there, bond order is more and strength also more. 2 bonds are there, bond order is 2 and strength is in between 1 and 3, and the bond strength of cc single bond is lesser compared to triple bond and double bond. So enthalpy is more for triple bond, that means sp hybrid orbitals, and after that sp2 hybrid orbitals, and then sp3 hybrid orbitals. Okay, so here if you see hybridization influences the bond length and bond enthalpy in organic compounds. The sp hybrid orbitals contains more s character, and hence it is close to its nucleus and forms shorter and stronger bonds than the sp3 hybrid orbitals. So here what he is using, s character. S character means, you see, s orbital is having spherical shape like this, spherical shape, and p orbital is having a dumbbell shape. So in the case of sp, that means this is one, this is one, this one orbital, this one orbital, that means s orbital percentage is 50%, p orbital percentage is 50%. So here 50%, 50%, this one, 1:1, that means 50%, this 50%. That means this s character, that means round shape, character means round shape, so that character is called s character, that means that is 50%. In the case of sp2, s is nearly 1/3, so 2/3 p orbitals are there, so obviously it is not 30%, it is 50% is 33%, around 33% s character and 66% p character is there. And sp3 hybrid orbitals, this is s 1/4 and this is 3 times, that means this is nearly 25% s character, this is 75% s character. So like that, in the case of sp hybrid orbitals, s character is 50%, sp2 hybrid orbitals s character is 33%, sp3 hybrid orbitals s character is 25%, and p character is accordingly I wrote here. Okay, so that is what it is saying. So s orbital s character means, what he is saying is here this bond is very nearer. These orbitals are very near to the nucleus. So those orbitals are electron means accepting nature will be there. That means electronegativity will be there for these orbitals because this is nearer to the nucleus. Nucleus is positive charge, so it will attract the electron density more. That means in the case of SP hybrid orbitals, it attracts the electron density more compared to SP2, that is having electronegativity in between SP and SP3, and SP3 is having least electronegativity compared to SP2 and SP. So electronegativity of these orbitals are SP is more, after that SP2, after that SP3. That is electronegativity. That means if we write the anions, this one, this is more stabilized because triple bond is there, more stabilized. Thus, that means this carbon stabilize this anion more. That means that carbon is more electronegative compared to this one, and comparingly this is least stable. This is least stable. So that is the reason this sp hybridized carbon is anion is more stable. That means carbanion is more stable, and after that sp2 hybridized carbon anion is more stable, carbanion. That means this is vinyl carbanion, this is acetylene carbanion, this is ethyl carbanion. So this is the stability of carbon ions. Okay, so here hybridization influences the bond length and bond enthalpy in organic compound. The sp hybrid orbitals contains more s character and hence it is closer to its nucleus and forms shorter and stronger bonds than the sp3 hybrid orbitals. The sp2 hybrid orbitals is intermediate in s character between sp and sp3, and hence the length and enthalpy of the bonds it forms are also intermediate between them. That is what I explained just now. The change in hybridization affects the electronegativity of carbon. The greater the s character of the hybrid orbitals, the greater is the electronegativity. That's what I explained. That means this sp hybrid orbitals are having more electronegativity. This is the electronegativity order: sp hybridization, sp2 hybridization, and sp3 hybridization. This is the electronegativity order. Okay. Thus, a carbon atom having an sp hybrid orbital with 50% s character is more electronegative than that possessing sp2 and sp3 hybrid orbitals. This relative electronegativity is reflected in several physical and chemical properties of the molecules, about which you will learn in the later units. Okay, those properties and all we will see as we complete the topics. So related properties will be discussed. We will stop here, and the next topic, some characteristic features of pi bonds, we will discuss in the next video. Thank you.